we start with where we stopped yesterday. Say we solved some numerical and all those things. In this chapter, and also in the last session, we learned L is equal to I omega. We proved this. I omega. We proved it. L is equal to I omega. I write it here. L is equal to I omega. L is angular momentum. I is moment of inertia. Omega is angular velocity. Say, most probably it is around 2003 or so, when I was head in Department of Physics, Sadvidya Composite PU College, 150th year celebrations was held there. And for one complete year it happened. For, say, closing down ceremony, we have 1 week long exhibition, open day like that, 1 week long. And in that, say, in the physics department, we created a beautiful experiment that is enchanting for all kids and even for elders also. What was that we want to think of? Okay. So in that experiment, there was a revolving stool which revolves on a base, a revolving stool. We ask the person who visits the stall there to sit on this. And we ask them to hold in their hand around 2.5 kg, 2.5 kg dumbbells. That's one dumbbell here and one dumbbell here. Totally 5 kg around. And then we ask them to stretch their hands like this. So we used to rotate them. We used to rotate them by holding their hand like this. Once rotation speed is so much, we don't touch them, they continue to rotate. Then we ask them to bring their hand near to their chest like this, along with the weights. Next moment is the enchanting for them. Many of them have been thrown out of the chair because it's made of, the chair top is made of steel. It's not with any other cushion or anything. It's very nice and very polished. As soon as they bring their hand nearer to their chest, they seem to thrown out of the chair. Many of them thrown out of the chair. Why it is happening, that we want to learn now. Say what I said, when they bring their hand near to their chest by folding like this, immediately their speed of rotation increases to large extent. They cannot sit there, they are thrown out of the chair. Like this. That's why it is very good thrilling thing on those days, in that lab. And one more thing, you might have seen the diving champions. How they dive, we want to learn. Just observe. This is the swimming pool and this is the diving board. Say in this diving board, a person stands, the diving champion stands, and once he dives, you know, most probably in the diving championship, they give points to so many rotations, just like in somersault. Even somersault also like this. Somersault is a gymnastic thing where they go on roll in the air once they jump. And that is called as twist. How many twists they perform, so much marks will be there for them, so much points. Thereby the winner is decided. Here in diving champion also, you might have seen that diving championship. Actually, how they count, once they fall into water, how many rotations they have given to their body is they count. They used to count half twist, one and a half twist like this. So now the idea, what we wanted to learn here is how the divers or how the gymnasts twist their body in the air For that, we'll see how they do it. Say they, as soon as they jump out of this, they bend their body so that they bend their head, they bring their legs near to their stomach, the hands very closely placed to their body, like this. They crouch their complete body like this. Then, because of this, they get a rotational motion. And the referees start counting one twist, one and a half twist like this. Just look into that. Nowadays, you can see it at any time. Just give in the Google search or YouTube the diving championship or divers. So then you will get, you can see how they jump. So once they jump like this, they go on twisting themselves in the air. But with the ambition of getting the prize, they cannot enter water like that. In one of the, say, international games, I have seen famous diver. Once he was falling there, because of something happened to him, he has not dived properly onto the water. He gave his back and the neck portion to the water, and he cannot come out of the water for a long time. Then their rescue operations performed, and he has been taken to the hospital. And finally, that is announced, he has died. Only because of falling. Why? Why it happened? Now we see. So we just observe. Once they started falling down, they crouch their bodies to create the rotation. But once they create the rotation, before entering to the water, they have to stop the rotation. They have to make a head as a way for their head to enter the water. Otherwise, if they end directly onto the water with their head, their brain hemorrhage may happen, because from such a height with such a velocity, water acts like a, say, concrete surface with so much of speed there, and it may create the injury. That injury made that person to die. That was a very famous diving champion also. So that's why what they do, divers, as soon as, say, just before entering into the water, they stretch their hands and they stretch their legs also. Once they stretch their hands and legs, the hands first touch the water. That makes a way for actually head to enter, and they enter come safely into the water. So observe here. Well, let's not bother about what happens once we stretch up. But before, in between this, we want to learn. Once they want to stop the rotation, they stretch their hand like this and stretch their leg. Their body becomes tight. So that stops the rotation. When they crouch their body like this, then they start rotating. To stop, they stretch. This is another example. We want to explain all these things a little later. Observe, there's one form of dancing in Russia, ballet dancing. Nowadays, we can see it only on YouTube. But when we were young, around, say, in 80s or 79, 78, in that region, up to 82, Russian delegates used to come to India. They used to perform in cultural exchange program or something like that. They used to perform many, actually, entertainment program. In that, we have seen ballet. Even now, you can see it on the YouTube channels. Say, what do you mean by ballet? It's a power form of dance, just like our Bharatanatyam or like that. In that ballet dancing, the dancer used to move throughout the dance like she is floating. How they achieve? They practiced in that dancing, used to walk with their toes, not lifting their leg. ಬರೀ ಹೆಬ್ಬೆರಳು ಮೂವ್ ಮಾಡ್ತಾ they used to walk. Against nobody actually feel she's walking. She simply floats over the surface of the dais. And not only that, wherever, so at some point they used to stop during the dance, they start quickly rotating like this, quickly rotating like this, quickly rotating. And how they do it, that is what we want to learn. There are many such examples. I am giving you third example. After this also I will give you one more. Later on we come back to the explanation. These are the beautiful things in the, as a physics, especially in this part of the physics. Now observe carefully with these things. So what ballet dancer used to do? Say this is the floor on which ballet dancer was standing, and she used to stand on her toes and hands are like this. When she wants to rotate herself at a particular place, what she used to do, she used to stand on single leg, she folds her another leg like this and hands near to her body. So she starts rotating quickly over her toe, one single toe on the floor. And it is for a few seconds. Actually, they are not at rest at any moment. They are moving throughout the dais. At some moment, they suddenly seems to come to rest. At that point, suddenly they start revolving. By doing this, after that, immediately after say a few seconds or few one within 1 minute, they used to stop the rotation and they start moving throughout the dais. How? Say once they want to stop, they used to do this. As soon as they want to stop, they stand on their toes and stretch one leg and hands like this. They immediately stop their rotation and they start moving on to another point. It's a beautiful experience to see this type of thing. It's a very well actually practiced thing because they used to walk on only toes, not lifting their leg at all. So that gives a beautiful feeling when you see that. Just see later on in today's. If it is possible, most probably on the YouTube channel. Otherwise, I will share you. So they used to stop their rotation. Not only this, most probably you have seen, say, fighting in Olympics, ice Olympics or something, Winter Olympics. There is one form of game, what is ice Olympics, where two men, one man and one woman, used to dance for a music on ice floor, where they also perform this type of thing. They used to rotate very quickly and then immediately stop, they start moving. Even in skating also, same things are happening. So how they perform all these things, how they start rotating quickly and how they come back to rest and how they move on to another thing. This is what we want to learn. Can you believe all these things can be explained very simply by this relation I omega. By this relation I omega. It's just simple. How much simple? It is what? Very, very simple. It is based on one of the very important rules of the nature, what we write now, or else let me write it as a law of conservation of angular momentum. Law of conservation of angular momentum. Law of conservation of angular momentum. It is based on that. You know, when does law of conservation of the angular momentum is conserved? We said long back. Actually, it's third or in the previous, say, fourth session or something like that, I have said. Whenever angular momentum constant, net torque is zero, we said, in case of earth revolving and all those things. In the same manner, here the reverse is true. For the angular momentum to be constant, torque is zero. Say in case of a person on a revolving chair, once we rotated them, we stop rotating them. They are holding their dumbbells in their hand like this, and they asked to bring it. So we stopped pushing them to rotate. They continue to rotate like this, and then they bring their hand like this. That means no torque is acting. We stopped pushing them. So no torque is acting means angular momentum to be constant. So once they stretch their hand like this, with the weights on their hand, that is the mr square, the moment of inertia is larger because r is larger. From there, as a central portion like this from their chest, the R is at larger distance with their, say, dumbbell to the dumbbells on their hands, like this. I'll write down that figure once again. Once they are sitting on the stool there, like this, or rotating stool, once they stretch their hand, the stretching is more, I is more, I large. That is moment of inertia is large because it is mr square, mass into radius. Mass is R is large, therefore mass square large. Once they bring their hand near to their chest and legs also near to the axis of rotation, the R becomes less. With the weight only they used to bring. R becomes very small. That means I becomes small. But observe now, L to be kept constant. Once they have stretched, I is large. To keep L constant, omega should be small. It is like this, for example. I write 10. I write 10. Omega is 2. Omega is 2. Angular momentum is 20 in the beginning, once they have stretched there. But once they bring their hands near to their chest and legs, the axis of the rotation, then immediately moment of inertia reduced because stretching is reduced, R is reduced. Therefore, to keep left hand side at 20, so we say the new moment of inertia is around 2 now. What happens to angular velocity now? Omega. Omega is 10. That is why they used to move very quickly, very fast. They cannot sit on the stool itself. They used to fall out of it, thrown out of it. So to keep angular momentum constant, the angular velocity increases almost 5 times. It is 2 here, it is 10 here. To keep it angular momentum at 20, omega becomes 10. That is 5 times larger. That's why they used to quick very quickly. So with this, not only with that, diving champion also, even with ballet dancers, observe now how they perform the quick rotation and stop. Say, once they want to rotate, they bring their hand and leg near to the axis of rotation, that is near to their one leg, where they are standing on a stool. Because of that, moment of inertia is small, I is small. So omega should be large. They start quickly rotating. Omega large. But once they want to stop, they stretch their hand like this, one leg like this, then R becomes larger. So moment of inertia becomes large. The second case. Moment of inertia increases and then angular velocity reduces, almost comes to 0 here. Even in case of divers also. Once they crouch their legs and hand near to their chest, along with the head like this, then their moment of inertia is less. They start rotating with some angular velocity. And once they want to stop, once they stretch their hand like this and stretch legs like this, moment of inertia is large, omega almost 0. They stop rotating. See? All these things can be explained on the simple footing of conservation of angular momentum. There's one more beautiful thing regarding this also. There's one circus company in most probably America. They created a world record in trapeze game. You know what is trapeze game? Do you know what is trapeze game? Trapeze means on the roof of the circus tent there, they used to have many swings. ಉಯ್ಯಾಲಗಳಿರ್ತಿದ್ವು ಈಗಲೂ ಇದೆ ಮಕ್ಕಳಿಗೆ ಸರ್ಕಸ್ ಬಂದಾಗ ನೋಡಿ ಒಂದ್ಸರಿ ಅಲ್ಲೂ ಒಂದು ಇದೇ ತರ ಐಡಿಯಾ ಐ ಜಸ್ಟ್ ಎಕ್ಸ್ಪ್ಲೈನ್ ನೌ ಜಸ್ಟ್ ಲುಕ್ ಹಿಯರ್ ಕೇರ್ಫುಲಿ ಇನ್ ದಟ್ ದೇ ಯೂಸ್ಡ್ ಇನ್ ದಿ circus thing there are a lot many swings here. Trapeze game means the personnel who are on these swings, they used to swing and they used to crisscross themselves flying from one swing to another swing. It is a thrilling thing. It's a beautiful thing to explain, to think, to see. Now, in one such game, that is called as trapeze. In one such game, American twin brothers created a world record. What it is, we want to learn. That can be explained again by using law of conservation of momentum, angular momentum. Say twins, one of them used to stand on one swing there. Another twin brother is standing on the other. Two. One here, one there. And what is the idea? What is they want to create a record means, once they are swinging, he has to shift over to here, to that swing. And as soon as he comes, his brother has to hold his hand and he has to pick up that, or he has to hold that swing and he has to get into that swing. But what they want to create as a record is, before holding the hand of his brother, their twin brother, he wants to create as many rotations as possible to his body. That's the record, in fact, what they wanted to create. For that, what they used to swing and he started jumping. Once he started jumping, just like diving champions, used to bring his legs and hand near to chest and bend his head. So he started twisting. He started twisting. And finally used to hold the hand or the string there. But do you know how many twists they can perform? Hardly two and a half, not more than that. That is the Guinness record, even today, most probably. Not more than that. Because of the quickness, they can give two and a half rotations there. And see, today you just see as an assignment three things: ballet dancer, ballet dancing, then diving champions, somersault, third one, fourth one. This you can see beautifully. Most probably recorded video is there on the YouTube. Say, give a Guinness record in trapeze, in circus. Then most probably it gives you a lot money. Otherwise, I'll share. So these are the things what we wanted to learn. As a first thing in this session, most probably we took half of the time of this class. But these are the beautiful things to learn. Now, in the remaining around, say, 25 minutes, or say, around 13 minutes or 15 minutes, we just go for the next idea. Say, here, today, we want to think of rolling. Till now, we learned translatory motion and rotatory motion. Rolling, we want to learn, because on rolling only, major things in the world are dependent. On rolling only, major things in the world are dependent. Because all the vehicles which move on the road, they have the rolling wheels. Rolling wheels. Even aircrafts, when they land on the airstrip, they have to depend on the wheel for them. For their landing or for their lifting also, they have to depend on the rolling wheel. So rolling is a beautiful thing to learn. But before that, I want to tell you one thing. Most probably, human beings' creativity rise to topmost extent in this world only 3 times, I guess. Not more than that. Topmost extent. In what sense I am saying topmost extent? It's an extra thing to compare to here. Say, what I mean by topmost extent is this. Let me explain it. There should not be any equivalent thing in the nature compared to that. What we have created, such things must not be have some analogies in the nature. Such analysis must not be there in the nature. Such things are most only 3 or 4. Can we guess one by one? First thing, what is there behind the internet, which is transforming the information? 0. Beautiful. That is the one of the moments where one of the Indian discovered 0 there. For all our calculations today, and what we count as so many gigabytes, so many terabytes, that is counted in terms of zeros and ones. Therefore, zero is the one more time, the finding of zero is one more time where the human being's mind rise to the topmost creative extent. Then two happened, wheel and zero. Fortunately, both of them are in the same shape. Wheel like zero is also zero. Okay. Then any other. One more. Most probably, how many of you know this? I don't know. It's a beautiful creative thinking. Can somebody tell me? ಎರಡಾಯ್ತು ಮಕ್ಕಳ. ಯಾಕೆ ಗೊತ್ತಾ? ವೀಲ್ ಯಾಕೆಂದ್ರೆ ಇಡೀ ಪ್ರಪಂಚದಲ್ಲಿ ಯಾವ ಪ್ರಾಣಿಗೂ ನ್ಯಾಚುರಲಿ ವೀಲ್ ಇಲ್ಲ ಮೂವ್ ಆಗ್ಲಿಕ್ಕೆ. ನೋವೇರ್ ಇನ್ ದಿಸ್ ಯೂನಿವರ್ಸ್. ನಮಗೆ ಗೊತ್ತಿಲ್ಲ ಬೇರೆದು. ನಮ್ಮ ಭೂಮಿ ಮೇಲಂತೂ ಎಲ್ಲೂ ಇಲ್ಲ ಯಾವ ಪ್ರಾಣಿಗೂ. ನಮ್ಗೆ ಗೊತ್ತಿರೋ ಪ್ರಾಣಿಗಳಿಗೆ ಅಥವಾ ಗೊತ್ತಿರೋ ಮೂವ್ ಆಗೋ ಯಾವ ಜೀವಿಗಳಿಗೂ ಇದಿಲ್ಲ. ಯಾವುದೇ ಜೀವಿಗಳಲ್ಲ, ನಾನ್ ಲಿವಿಂಗ್ ಥಿಂಗ್ಸ್ಗೂ ಇದಿಲ್ಲ. ನಾವು ಕ್ರಿಯೇಟ್ ಮಾಡಿದ್ದು ವೀಲ್ಗಳನ್ನ. ಫಸ್ಟ್ ಜಸ್ಟ್ ಮೇಕ್ ಎ ಸ್ಮಾಲ್ ಅಸೈನ್ಮೆಂಟ್ ಫಾರ್ ದಟ್. Mobius strip. It is one more beautiful idea. Mobius strip. ಈಗಲ್ಲಿ ನೋಡಿ, ಇಷ್ಟೆಲ್ಲ ಕಲ್ತ್ರಿ. ರೋಲಿಂಗ್, ಅಲ್ಲಿ ಟು ಕ್ರಿಯೇಟಿವ್ ಥಿಂಕಿಂಗ್ ಐಡಿಯಾಸ್ ಕಲ್ತ್ರಿ, ಎಲ್ಲ ಕಲ್ತ್ರಿ. ಇನ್ಯಾವ ಅಷ್ಟು ಮಾಡಬೇಕು. ಮೆನಿ ಮೋರ್ ಥಿಂಗ್ಸ್ ಟು ಕಮ್ ಫ್ರಮ್ ಯುವರ್ ಸೈಡ್. ಯಾಕೆಂದ್ರೆ you're all youngsters, you're all in 17s or 18s, and you have to create many more such things. ಎಲ್ಲಾನು ಬೇರೆಯವ್ರು ಬಿಟ್ಕೊಡ್ಬೇಡಿ ಮಕ್ಕಳ. ಇಂಡಿಯನ್ಸ್ ಆಗಿ ನಾವು ಎಲ್ಲರಿಗಿಂತ ಚೆನ್ನಾಗಿ ಯೋಚನೆ ಮಾಡ್ತೀವಿ. ಏನಾದ್ರು ಒಂದು ಕಂಡುಹಿಡಿಯೋಣ ಅಲ್ವಾ? ವೈ ಡೋಂಟ್ ಯು ಟ್ರೈ ಫಾರ್ ದಿ ಫಸ್ಟ್ ಟೈಮ್? ಓಕೆ. ಸೊ ವಿತ್ ದಿಸ್ ನಾವು ರೋಲಿಂಗ್ ಮೋಷನ್, ಇನ್ ಫ್ಯಾಕ್ಟ್ ಇದಿಷ್ಟು ಹೇಳಿ ನಾನು ನಿಲ್ಲಿಸ್ತೀನಿ, ಕಂಟಿನ್ಯೂ ಮಾಡಲ್ಲ, ನಾಳೆ ಕಂಟಿನ್ಯೂ ಮಾಡೋಣ. ಇನ್ ದಿ ರೋಲಿಂಗ್ ಮೋಷನ್, ಇಟ್ಸ್ ಎ ಕಾಂಬಿನೇಷನ್ ಆಫ್ ರೊಟೇಷನ್ ಆಸ್ ವೆಲ್ ಆಸ್ ಟ್ರಾನ್ಸ್ಲೇಷನ್. ಯಾಕೆ? ಇದಿಲ್ಲೇ ನಿಂತ್ಕೊಂಡು ಸುತ್ತಲ್ವಲ್ಲ, ಸುತ್ತಿದ್ರೆ ರೊಟೇಷನ್ ಆಗೋದು, ಅದು ಮುಂದಕ್ಕೂ ಹೋಗುತ್ತೆ. ಆಯ್ತಾ? ಟ್ರಾನ್ಸ್ಲೇಷನ್ ನೋಡಿ ಇಲ್ಲಿ. I mark a point C, which is a point of contact of the wheel and the road, wheel and the surface. This point is always at rest, and this point is always ever changing. ನೋಡಿ ವಿಚಿತ್ರ ಇದು. ಈ ಪಾಯಿಂಟ್ ಅಂದ್ರೆ ಆ ಪಾಯಿಂಟ್ ಅದೇ ಪರ್ಟಿಕ್ಯುಲರ್ ಪಾಯಿಂಟ್ ಅಂತ ನಾನು ಹೇಳ್ತಾ ಇಲ್ಲ. ಈಗ this point acts as a, say, line passing through this point acts as axis for rotation of the wheel. Rotation of the wheel.